James Webb Space Telescope has revealed an extraordinary supernova deep within the Pinwheel Galaxy, found between the constellations of Ursa Major and Bootes. A massive star, much bigger than our Sun, has exploded, scattering elements like iron and carbon across the universe. This incredible event is the nearest supernova to Earth we've seen in 10 years, lighting up our night sky. What hidden secrets could this huge space explosion show us about our universe? Join us to witness the real footage of this spectacular cosmic event live now. Guess what? The James Webb Space Telescope just caught a massive star going out with a bang in a distant galaxy, lighting up the cosmos. The James Webb Space Telescope has captured a spectacular burst of light from a supernova, far off in the universe in the Pinwheel Galaxy, also known as Messier 101 or M101. This galaxy, located millions of light-years away from us, is like a giant star city full of stars and cosmic leftovers, stretching across 170,000 light-years. This particular star was way bigger than our Sun and had been burning its fuel for millions of years. Eventually, it got too heavy and blew up. Now, can you witness a supernova? Well, you can watch SN 2023 AXF as it bursts into brilliance live online. This isn't just any supernova, it's one of the biggest and brightest explosions seen in the last decade. Tune in for free via the Virtual Telescope Project's website or their YouTube channel, where their powerful telescopes in Rome, Italy will capture every moment of this cosmic spectacle. Just remember, the schedule might change if the weather doesn't cooperate. This stunning supernova was first noticed on May 19, 2023, by Koichi Itagaki, a well-known supernova hunter from Japan. A day later, it was confirmed by the Zwicky Transient Facility in California. Located in the Pinwheel Galaxy, which is also a part of the famous Big Dipper, this supernova is remarkably close to us, only 20 million light-years away. Its increasing brightness makes it an exciting object even for amateur stargazers, who can spot it as a faint dot of light with simple telescopes. The Virtual Telescope Project, guided by the renowned Italian astrophysicist Gianluca Masi, emphasizes how special it is to view this supernova. It sits in one of the most beautiful spiral galaxies in the sky, making the experience even more breathtaking. Even more thrilling, sophisticated tools like the Hubble Space Telescope are now zooming in on this supernova to study it in greater detail. By tracing a line from the Big Dipper's handle stars, Alioth and Mizar, and extending it outwards, you'll find M101. For those familiar with night sky navigation, you might spot the supernova shining unusually brightly on one of the galaxy's spiral arms. This extraordinary supernova will remain visible in the Pinwheel Galaxy for the next few months, before it gradually dims and disappears. If you're serious about getting a closer look, consider investing in a good telescope or binoculars, following recommendations for the best viewing experience. Each twinkling light in the night sky has a tale of cosmic life and death, just waiting to be told. What will the stars reveal next? Betelgeuse is acting weird again, and it's got everyone talking. The process of mass loss from the star Betelgeuse has piqued curiosity due to the expelled material showing signs of possible chemical complexity. The James Webb Telescope's findings have challenged previous beliefs, suggesting that molecules and possibly organic compounds could survive in the harsh environment around a dying star. These observations have sparked discussions about the chemistry that occurs around supernovae and the types of molecules that could form in space. This newfound understanding has also improved predictions about when Betelgeuse might go supernova, thanks to more accurate measurements of its size and temperature. These metrics are crucial for models that predict the lifespan of large stars. Yet Betelgeuse still has more secrets to reveal. As we continue to examine it more closely, we expect to uncover even more layers of complexity. Our journey into the deeper aspects of Betelgeuse through recent observations by the James Webb Telescope highlights the star's mysterious nature and marks the beginning of a new era in cosmic exploration, one where each discovery leads to more questions. Betelgeuse, located about 642 light-years from Earth in the constellation of Orion, is a key target for both amateur and professional astronomers. Its pulsating behavior, which is not a simple, regular pattern but rather an irregular one, makes it a challenging and intriguing subject for study. Recent studies have shown that Betelgeuse's size is so variable that its diameter can fluctuate up to the distance from the Sun to Mars. This revelation raises doubts about the stability of red supergiants and points to a highly unstable phase in Betelgeuse's life cycle. Moreover, the star's surface features enormous spots, much larger than those on the Sun, which affect its luminosity. These spots indicate strong magnetic activity, which further complicates the pulsation pattern of the star. The complex atmosphere surrounding Betelgeuse, filled with gas and dust, forms a nebula around the star and contributes to its ever-changing appearance in the sky. This raises fascinating questions about the nature of mass loss in red supergiants. Observing Betelgeuse offers a window into the secrets of stellar evolution and the turbulent life of a dying star. When stars like Betelgeuse eventually explode into a supernova, their cores collapse under the force of gravity, leading to the formation of either a neutron star or a black hole, depending on the initial mass of the star. Such cosmic events fundamentally alter their surroundings and contribute to the cycle of stellar birth and death. Supernovae also enrich the cosmos with elements heavier than iron, which are essential for the formation of planets and life as we know it. The material ejected by a supernova interacts with surrounding gas and dust to form new stars and planetary systems, highlighting the interconnectedness of cosmic events. The shockwaves from the explosion can also trigger the collapse of nearby dense molecular clouds, potentially accelerating the formation of new stars. As for the potential effects of Betelgeuse's supernova on Earth, despite the star's significant distance of about 642 light-years, it could become the brightest object in the sky for a time, transforming night into twilight. Such an event could impact nocturnal wildlife, altering their patterns of predation and navigation. However, the direct effects on Earth would be minimal due to the vast distance, though the spectacle would be a momentous one in astronomical history. Betelgeuse could turn our night sky super bright soon. What else might be out there in space, just waiting to surprise us? Did you know some stars go out with a bang so huge you can see them in the daytime sky? That's the wild story of supernovas like SN 1054 and SN 1604. The story of supernovas like the famous SN 1054 that created the Crab Nebula and SN 1604 observed by Johannes Kepler is quite fascinating. These incredible cosmic events were so bright that they could be seen during the day from Earth. They've taught us a lot about how stars evolve, but even though they were close enough to light up the sky, they were still too far to affect Earth physically. In the same way, when Betelgeuse eventually explodes in a supernova, we expect a brilliant show in the sky, but no real danger to us on Earth. Betelgeuse is bigger and closer than many other stars that have gone supernova, so it's bound to give us even deeper insights into the secrets of supernovas, like how neutron stars or black holes form and how heavy elements are created. This could be a golden opportunity for scientists to learn more. The last time we saw a supernova with the naked eye in our galaxy was SN 1987A, in a neighboring galaxy called the Large Magellanic Cloud. Now, when we talk about supernovas posing a danger through cosmic radiation, they need to be really close, like 50 light-years close, to cause significant damage to our biosphere. Luckily, Betelgeuse is over 600 light-years away, so there's no risk of it increasing cosmic radiation to dangerous levels on Earth. These explosions not only might create fascinating objects like black holes or neutron stars, but also offer a unique lab for astrophysical research. By studying what's left after a supernova, scientists can uncover more about the life cycle of massive stars and the properties of these awesome cosmic events. If you think the rhythmic pulsing of Betelgeuse is mysterious, wait until you dive deeper into the cosmic dance of stellar life and death. The tale of supernovas is still unfolding, a saga of massive creation and destruction. It's like a fireworks show in the cosmos, holding secrets about the birth of stars, the creation of elements vital for life, and much more. Supernovas come in two main types, each playing a unique role in cosmic evolution. Type Y supernovas happen in binary star systems where a white dwarf absorbs material from its companion. Once it hits a critical mass, it collapses and explodes. This type doesn't scatter many heavy elements, but it's crucial for measuring cosmic distances because of its consistent peak brightness. Type 2 supernovas occur when massive stars run out of fuel for nuclear fusion and collapse under their own gravity. This collapse spews out the star's outer layers and is vital for distributing elements like carbon, oxygen, silicon, and iron throughout the galaxy. Depending on the mass of the star, this collapsing core might turn into a neutron star or a black hole. Beyond just making elements, supernovas can trigger the formation of new stars by compressing interstellar gas and dust. This ensures that galaxies remain lively and dynamic, evolving with each generation of stars. In this way, supernovas are not just powerful and mesmerizing events, they are essential for the chemical and dynamic evolution of the universe. So while Betelgeuse won't mess with Earth when it finally explodes, it's going to be one heck of a show, reminding us just how amazing and full of surprises the universe really is. Did you know that supernovas are not just spectacular light shows but also crucial recyclers in the universe's vast ecosystem? Let's dive into the cosmic cycle where stars meet their explosive ends and give birth to new celestial wonders. Supernovas play a really big part in what we can call the cosmic cycle of matter, almost like they're part of a huge ecosystem where the end of one star sets the stage for new cosmic bodies to emerge. Studying supernovas helps us understand some pretty extreme physics, like how stuff acts under intense pressure and heat, how shock waves in plasma behave, and what neutrinos, those super hard-to-catch particles important in the whole star collapse scene, are up to. Diving into supernovas not only tickles our cosmic curiosity, but also lights up the paths that led to the creation of our planet and even us. When we look at stars like Betelgeuse, Antares, and the imagined giant Musfi, we're peering into the dramatic lives of some of the most massive and interesting stars in our galaxy. Each of these stars brings something special to the cosmic stage. Betelgeuse, for instance, is a red supergiant with a radius about 1,000 times that of our Sun. Its brightness changes a lot because it's pulsating, which together with stellar winds makes it seem like a star on its last legs. Antares, although a bit smaller with a radius around 700 times that of the Sun, still packs a punch with its deep red glow and its own bright variable show that can sometimes outshine Betelgeuse. Antares, with a significant mass loss and a mass about 12 to 17 times that of our Sun, showcases the diverse paths that stellar evolution can take. Then there's the theoretical Musfi, a hypothetical star that if real would push boundaries with a radius 1,500 times that of our Sun and shining so brightly it could dwarf the light from both Betelgeuse and Antares. Musfi, with a massive 25 times the mass of our Sun, would be a top contender in the heavyweight category of red supergiants, offering even more clues about the dynamics and variability of such cosmic giants. Exploring the histories and characteristics of Betelgeuse, Antares, and Musfi shines a light on the tremendous variety and activity of stars across the cosmos. The differences in size, brightness, and mass among these celestial giants underscore the complex nature of stellar evolution and remind us of the dynamic, ever-changing universe. Thinking about the future of these stars helps us appreciate that each star has its own story, contributing to the grand narrative of the universe, a narrative that continually reshapes our understanding of the cosmos and our place within it. From Antares to Musfi, we've seen a wide range of cosmic possibilities, but what does the future hold for these giants? The answers could forever change how we view the night sky. Betelgeuse, standing as a colossus among stars, highlights that stellar evolution is a complex process that varies greatly with the mass of the star. By comparing our Sun's predicted end to that of Betelgeuse, we get a glimpse of the different fates stars can meet. Betelgeuse is nearing the end of its life, likely to go out with a bang in a spectacular supernova explosion, not just quietly fading away. This dramatic end comes because a star of its mass can no longer fight the inward pull of gravity once it's burned through its nuclear fuel. In contrast, our medium-sized Sun is in its main sequence phase, calmly fusing hydrogen into helium in its core, a process expected to last another 5 billion years. After this, it will expand into a red giant, possibly swallowing Mercury, Venus, and maybe even Earth before shedding its outer layers to form a planetary nebula. What remains will be a white dwarf, a dense, cooling leftover of the star it once was, slowly fading over trillions of years. While massive stars like Betelgeuse have fast and furious lives and deaths, using up their nuclear fuel quickly and dying spectacularly, their explosive demises enrich the interstellar medium with heavy elements, fostering the birth of new stars and planets. On the other hand, the Sun's more gradual transition to a white dwarf will have a less immediate impact on its cosmic surroundings. but its eventual passing will significantly affect our solar system, particularly the inner planets. Understanding the stellar evolution of stars like Betelgeuse not only offers insights into the ultimate fate of our sun, but also shows how the cosmos operates as a cycle of matter and energy. This cosmic ecosystem relies on the recycling of materials from star and planet deaths, whether through explosive supernovas or the more gentle shedding of planetary nebulae. Observing how these vastly different stars evolve highlights the diversity of stellar paths, all governed by the same physical laws but resulting in dramatically different outcomes based on their initial masses. What big bangs are waiting for these huge stars in the ever-changing universe? Are they all natural, or is something else going on? Supernovas are giant space factories, making the stuff everything is made of deep inside huge, hot stars. Supernovas, especially when they burst, work like giant cosmic workshops. They produce many of the heavier building blocks that make up the various chemicals in the universe. This happens in the hearts of very big stars that are super hot and squeezed tight, allowing them to merge atoms in ways small stars like our sun cannot. Understanding the lives of these big stars, from their early days shining brightly to their later years as red giants and finally bursting as supernovas or turning into black holes, brings new challenges and helps improve our understanding. We have to think about how these stars lose bits of themselves, change in brightness, and deal with the complicated atom-merging processes that last their whole lives. Red giants are really important for learning about how stars change because they show us how these processes guide the creation of stars. These giants play a big role in balancing the creation and end of stars in our galaxy. The big bursts from their supernovas can squeeze nearby gas clouds, starting the birth of new stars. But these bursts can also spread materials around, which might slow down the making of new stars in some places. This makes red giants like Betelgeuse very important for scientists studying star atmospheres, star winds, and the final stages of a star's life. Watching these stars makes us question what we know and leads to new ways and tools in star science. Betelgeuse, a big red giant, is more than just a cool light in the night sky. It plays a key role in the movement of matter and energy, affecting both the chemical mix of the universe and the birth of new stars and planets. While we don't know exactly what will happen to Betelgeuse in the end, we do know it will one day burst into a supernova, which will be a major event marking the end of its life as a red giant. This change is coming, but it could happen any time from now to thousands of years in the future. The soon-to-happen supernova of Betelgeuse gives us a special chance to closely study how such big cosmic events work, which could really change our understanding of the universe. Watching this supernova, especially since we've watched Betelgeuse before it explodes, would be a first in modern star science. It will help us learn what leads up to these big bursts. Its explosion is expected to be so bright that it could be seen during the day, offering a sky show not seen for hundreds of years. From a science point of view, the supernova will let astronomers watch the making of elements heavier than iron as it happens. Also, the shock waves from the explosion could start the making of new stars in nearby gas clouds. This process is key for balancing the rates of star births and deaths in galaxies, and adds to the cosmic cycle of matter, important for building future stars and planets, maybe even those that could support life. Talking about what might happen when Betelgeuse explodes also highlights the big role red giants play in making chemicals and their contributions to ideas about how stars change. Thinking about when and how Betelgeuse's supernova might happen adds an important chapter to our knowledge of the galaxy. Betelgeuse is ticking down to explode, and we're on the edge of discovering star secrets like never before. Thinking about Betelgeuse blowing up helps us see how each star's big bang starts a whole new chapter in space,